Thank you all for joining us today. And if you've been watching these other webinars, this is actually kind of our third part of this series. We started off with battery testing, then we did voltage drop testing. Today we're finally doing alternator. Hopefully you've not been waiting on us to actually test that alternator since we first started this program. But I think it's very important that whenever you look at any of these, that we got to treat the charging or cranking system as that. They are systems. There's multiple parts of it. And when we talk about today, we're going to remember that the alternator is only part of that charging system. And we're going to do a little bit of refresher from our previous ones, but whether you're going to try to troubleshoot a starter, try to shoot an alternator, those are always the last things we're going to do. The first one we should always be checking is batteries. So kind of, again, a little bit of refresher on some of this and make sure we're all talking the same language. That first term we're going to talk about is voltage. The voltage is the electrical pressure. That if you put your multimeter across the battery, it says it has 12.5 volts, that means that battery has 12.5 units of electrical pressure, trying to push current. This brings us to our next term, which is amperage, current, juice, flow, whatever one wants to call it, but that is what that voltage is trying to move, is the current. And current's what it takes to operate the starter, and that's what the alternator produces, trying to recharge those batteries. We got to make sure we got the right voltage to move that current to whatever direction we're going. And the last term is ohms. That's simply resistance. That whether we're talking about an electrical circuit or a water circuit, that you can have all the pressure at the source, but if you have, a kinked hose or a corroded wire, that is adding resistance to the flow of that electricity. So those are all very important when we talk about this. What does all that mean? It says, hey, anytime we're talking about a complete circuit, we're going to start at the battery, we're going to go through the starter, come back out the ground side and back to battery. It's a complete circle. That anywhere we have corrosion or damage or a weakness in that circuit, it's going to impact that device's ability to perform properly. Shop equipment, today, and just like I said from some of the previous one that we talked about, battery testing or voltage drop testing, is most shops have, some form of one of these testers. Obviously, we're spending the most time talking about the ones that we work a lot with and have sold a lot of our customers, is the BVA tester on the left and the BCT tester on the far right. Both those are derivatives of the old-fashioned carbon pile. That's what every shop used to use. That's what I first started training on, was the old-fashioned carbon pile. The electronic testers have made it much easier now because they allow us to do a snapshot of these tests or to give us menu-driven prompts to make sure we do it right. But as we said before, batteries are the heart of the electrical system. They are more than just 4 black boxes inside that truck or bus or whatever we're working on. It may have only 1 battery or 2 batteries or 3, but no matter what, we got to make sure those batteries are right before we go any further. When we talk about batteries, keep in mind, some of the things that I talked about before, or Jimmy talked about in the last segment of this, was those battery ratings. What do they mean? Battery CCA rating is cold cranking amps. That is the amount of energy that battery can give off at 0 degrees. Reserve capacity, that is the amount of energy that battery can give off with a 25 amp load and still maintain at least 1.75 volts per cell. That's really what's more important anymore when we look at batteries and make sure we're using the right battery for the job, is how much energy can that battery store. That people still have a tendency when they look at batteries is bigger's got to be better, so they look for a high CCA, and that's not always what you want. So when you're doing your tests and going through these, is take a look at those ratings. Is this the right battery for the application? Ampere hours. Again, this is just some background on this, but when we look at batteries, make sure we understand what an ampere hour is. A lot of times we give drivers a hard time because go out, you got a truck on the yard that's got dead batteries, and you ask the driver, what did you leave on? Guess what his answer always is? Nothing. He didn't maliciously do anything, but a lot of times they don't understand what that load is. That if you have a 1 amp load on a battery and it's on for 1 hour, you've pulled 1 ampere hour out of that either single battery or battery pack. If it's a 10 amp load and he's left it on for 1 hour, or she, doesn't matter, the driver, or technician left lights on because he moved truck out, but that comes out to 10 ampere hours. You swap the numbers around, it's 1 amp, you leave it on for 10 hours, 10 ampere hours, 10 amps, 10 hours, 100 ampere hours. And the reason this is important is, one is we need drivers to understand this, but we also need technicians to understand this. That if you do have low batteries, you cannot take your shop charger, put it on fast cook, put 50 amps in those batteries, leave it on for a half hour, because what did you put in? If it's 50 amps and you only left it on for a half hour, you only put 25 ampere hours back into that battery pack. So did you charge them? No. Do people do that and then try to test an alternator? Yes, you can very easily condemn a perfectly good alternator because you're really still trying to test it with discharged batteries. And we talk about batteries as, here's state of charge versus the open circuit voltage. Generally, we're looking for at least 12.4 volts to be in those batteries so they can be properly tested. If not, it's like trying to find a hole in a tire if it has no air in it. That they have to have enough energy in them to properly load test those batteries. So if they're not, you need to charge them or replace them to make sure those batteries are good. Battery tools. Is several different adapters out in the market. Now a lot of them are also starting to offer a brass one. Bottom line, doesn't really matter which one you use. If you use lead ones, the steel ones, my probably preferred one is the one on the far right. It's extra tall because some of the batteries may have taller studs than normal. The other adapters may bottom out when you try to use them. Not nearly as bad about getting slime and grime in them. That's some of the trucks with all the grease they use, you wind up with these other adapters being packed full and they don't go all the way down. But it's imperative when you load test a battery, or even when you charge a battery, that you get that lead adapter all the way down the lead pad. On a Group 31 stud type battery, that lead pad is your electrical connection. That stainless steel stud is only there for mechanical connection to hold those cables down and make sure you're getting a good connection against them. If you try to load test a battery and don't use those adapters, you're not going to get an accurate testing and very easily condemn perfectly good batteries. Same thing when you're trying to charge them, that if you're not down making good connection, you're going to have a harder time charging those batteries. And with a lot of the electronic type battery chargers that are out there, they could pick it up as a defective battery and shut down when, again, there's nothing wrong with it. Just wasn't getting a good connection. But the battery brushes do a wonderful job of cleaning those. They're available through us or a lot of other sources. Or you can just use, one of the little toothbrush type wire brushes. The point is, you got to get it clean. Some of us don't want to spend a whole lot of time with because, again, we've done these before. But take a look at those batteries. If those batteries are damaged, either physically damaged, they've been damaged from not having hold downs in them, over tightening. When I say over tightening, that can either be the hold down bar, someone is way over tightened and deformed those batteries, or it can be someone using the impact on the battery nuts. Keep in mind, torque on a battery nut is only 10 to 15 foot-pounds. So if you get in there with an impact, I don't care how worn out it is, we'll only use them to break it loose, that you're going to upset that stud that's in that lead pad, and you're going to cause a high resistance contact. So avoid power tools. State of charge, put a quick voltmeter across it. Are those batteries at a high enough state of charge to test them? And then you're actually going to load test them. Here's some of the examples of the battery case that wasn't a hold down use, so that battery was bounced around, came down on something, and was damaged. Two examples here. The one on the left was a battery nut that was left loose, and every time they cranked the engine, it was arcing on the stud there and damaged it. There's no way you're going to fix that battery. You need to take it out. Maybe great for your fishing boat, but ain't going to be good for a truck that's not out on the road. The one on the right's actually in good shape, other than it's just dirty. If you try to test through all that, again, you could condemn a good battery. That's what that battery brush will do. Give you a nice clean pad. The other thing I do is look at this pad and see if you have a nice flat surface. I was at a fleet one time where they, just historically always used impacts. You could actually see the hex of that bolt working itself up through the lead pad. Cables, this is something everybody always forgets, that the cables are just important. While you're doing the battery service, make sure all this is clean. You got it apart, you should be cleaning it. This happens to be a Freightliner where the battery box is between the frame rails. Uses a daisy chain type cable where it goes from one battery to the next, all as one cable assembly. The problem is everybody pulls the 4 nuts off to take the cables loose to test the batteries. They never take the main cable connections loose. So these have not been apart since the truck was built. They're all kinds of corroded, maybe rusty. No matter what, it's not giving you a good connection. So make sure you clean all those things. Also, all the different wires that are on there. That a lot of OEMs will connect, directly to the battery for ECU power, automatic transmission power. They have a separate power for cab feed. All those things need to be cleaned and inspected when you're doing these. Again, you have the best batteries in the world. If you don't have good cables getting that power up there, you're not going to get a fair test on the entire system. But make sure those adapters are all the way down. Check each battery individually. There is test equipment, including what we're talking about, that does have battery banks, and there's time to use a battery bank tester. If you have a write-up for an electrical problem, or you're going to be checking the alternator, or whether it's cranking system problems or charging system problems, you need to go ahead and take it apart, do all those things to make sure the system's ready. Surface charge, when we talk about that, is batteries that have been on charge, either a shop charger or the truck's been going down the road. If those batteries have over a 12.75 volt state of charge to them, says they have a surface charge. The new modern electronic testers that we showed you earlier will automatically put a load to burn that surface charge off and then do the actual battery test. Replacement battery, our rule of thumb generally is replace batteries in the system. That doesn't mean you have to put 4 batteries in every time or 4 new batteries in time. They can be good recharge batteries, but the idea is we're trying to keep them as a match set. You want batteries to be within 6 months of each other. You want them to be within 50 CCAs of each other. I try to keep them the same manufacturer, and never, never, never mix AGM and flooded cell. I was looking at a liftgate earlier this week, and there was 3 different models of batteries in a 4 battery compartment. Talk about destined for failure, but 2 of them were AGM, and there was 2 different oddball flooded cells in there as well. The other thing too is retighten those battery cables with the right torque. Do I expect somebody to break out a torque wrench, do their battery nut? No, that's never going to happen. But again, no power tools, and make sure you're not getting over carried away. Don't use a half-inch breaker bar to tighten battery nuts. It's only, again, 10 to 15 foot-pounds. And we talk about the charging circuit. That when we went through, we tested the batteries, we know they're good. Next thing we got to do to make sure we're ready to test the alternator is make sure this charging circuit's good. This is a very basic system. You have power and cable on most OEM goes from the alternator to the starter, and then they use the main cranking cables to go back. So we want to make sure these cables are good. The other thing too is we want to make sure we understand how an alternator works and how that system works together. That if everything's great, you got a truck going down the road, you have a 135 amp alternator, and you have 55 amps worth of vehicle loads. That gives you 80 amps, still available. Those batteries are discharged. Every battery is going to get about 20 amps. There's going to be a little bit of difference between batteries, but for the most part, each battery is going to take an equal amount of what's available, and life is good. The batteries will recharge, and things are great. But what happens if you happen to have a battery with a shorted cell? If you look at the third battery's got a shorted cell, where do you think all the energy is going to go? You still only have 50 or 80 amps of available energy because the vehicle loads are consuming 55, but all that 80 amps is going to go to that one defective battery. Guess what the other 3 batteries are going to do? They're also going to discharge, trying to help their brother out and maintain that system voltage. When are you going to realize you have a problem? One, if you watch the voltmeter is going to continuously go down, lower and lower, because the system voltage is going to deteriorate as it absorbs all that energy. You may start noticing rotten egg smell. Batteries get hot. But if you were to try to check the alternator in this condition, what would you find? More often than not, they're going to condemn it because the alternator is only putting out 13 volts, and it's hotter than hell. That's That alternator's been doing everything it can trying to charge those batteries. So byproduct of that is lots of heat. And because those batteries are not coming up, you're still going to see a very low voltage and easy to condemn the alternator. What's wrong with the alternator? Absolutely nothing. It's doing exactly what it's supposed to. It doesn't know you've got defective battery there. Which kind of goes back to, misdiagnosis, whether, driver caused or technician is, you cannot check an alternator, by the truck voltmeter. One is right now, if you look at that, the first thing someone will say is, alternator must not be working, it's only 13 volts. Well, if those batteries are very low, again, what's that alternator, voltage going to be, or the charging system voltage? It's going to be very low, because that alternator could be doing exactly what it's supposed to, putting out all the current it can, but because that defective battery is absorbing it, or it may just simply be 4 severely discharged batteries causing this condition. Flip side of that is you can have a voltmeter that looks good. That, for example, you got a 135 amp alternator we're talking about for. If it had one defective diode, what is that 135 amp alternator now? It's only a 90 amp alternator. You lost a third of the performance of that alternator. As long as you don't have very much load on, what's the voltage going to be? It's going to look good. Everybody's going to think everything's great. And this is something you'll typically see through, fall and winter, where you don't have nearly the electrical loads. You can have a defective alternator all that time, but loads are small, so everything looks good. When we roll around to springtime and start turning on air conditioner and some of the extra loads, suddenly we have a road call because that alternator finally gave out because of the environment it was in. With low loads, everything looked good and was able to work. The other thing, too, is if you do have one diode out, what's the odds are you're going to lose a second diode? Now you go from a 90 amp alternator to a 45 amp alternator. So a voltmeter, especially the vehicle one, is not ever a good diagnostic tool. Battery alternator interaction, the batteries have to be charged. The regulator works on based what they see at the battery, which brings us to another point here is typical heavy-duty charging systems have always been a one-wire system, which means all it takes to work really is a positive cable at the output terminal, which was fine for years, and then we came about with the remote sense. Because the problem with this one wire, since that is the only connection, is that alternator or the voltage regulator reads the voltage at the output terminal. Says, hey, I'm at 14 volts, life is good, I should have no problems. But if you have, say, undergauge cabling, damaged cabling, corroded, loose, whatever, are you ever going to get the right voltage or that 14 volts back to the battery? And the answer to that is no. So remote sense came out. Oops, I clicked twice. Oops, I'm just missing a slide. But I'm going to go through the post here that, again, this is the output terminals post, which obviously is your main cable going back to the batteries. Next, you have an R terminal, a relay terminal. This is always half rectified voltage. So if you're at 14 volts at the output terminal, you should be at approximately 7 volts here. Way back when, this was also a pickup for tachometers. It would actually pick up the pulses of the rotor inside and then convert that based on pulley ratio and tell you what your engine speed was. Next one is I terminal. Everybody refers it to as idiot light. That if the alternator is working, that should have 14 volts at it, or basically output voltage. Volvo's really the only one that uses this. If you ever did need to get a 12 volt signal when the engine's running, you can do that because again it'll only have power if the engine's spinning and the alternator has output. Just be careful, you can only put a 1 amp load on it. It's really only designed to power that light in the dash. The last one we're going to talk about is that remote sense terminal. This was an extra post where we could run a wire from the alternator all the way back to the battery pack, so we could regulate based on what the batteries were truly at. So, hey, I'm only getting 13.5 back at the batteries. Well, then the alternator could go up to 14.5 to make sure we're getting full voltage back of that battery to compensate for any deficiencies in the charge circuit. But I just got out of line with mine. But here's an example of how that wire is ran. It used to be all the OEMs ran it straight to the batteries. Some now run it to the starter because with the big main cables there, they figure they should get a very close to battery voltage without having to run it all the way back. Depending upon alternator, if this wire is not hooked up, or if the inline fuse for this wire is blown, they will revert to a higher setting, kind of a worst case scenario. So if you ever check a truck and the tester says high regulation voltage, or if you put a voltmeter on it, you see higher than normal voltage, make sure you check this wire. We're talking about the cables and circuits on this truck. Is take a look at them. All these cables are routed through some sort of hold downs or brackets, wire ties. I can assure you if the OEM didn't think these were necessary, they wouldn't have put them there. So take a look, make sure they're there. The last time someone changed an alternator or put a radiator in the truck, did they reroute them and retie them properly? This is a very big cable, not only the charge cables, but the cranking cables as well, and they are not protected. So if you don't secure them properly, easy way to wind up with a thermal event that nobody wants to see happen. Again, visual, take a look at all these. If the cable's corroded, it's green, you got bulges in insulation, bad crimps. It looks like someone recently just worked on this thing, and it's they did a crimp with a hammer. Probably not the best electrical connection. You need to take a look at it. And one thing about cables is the OEMs don't give us any more than they absolutely need. If it's 100 inches from point A to point B, you're lucky if they make that cable 100 inches. So if you start seeing damage or bad crimp or insulation, rubbed off, chafed, any of these things, better to address it now and fix it before you wind up having to replace that entire cable. A lot of the new trucks, with the way they route those cables and everything, a cable replacement can be an 8 or 10 hour job to do it properly. So make sure you take a look at it. I would much rather fix a cable, though, than replace a starter on today's truck. Make sure you use heat shrink, and try to make sure you always use the right color heat shrink. That positive cable should have red, and negative cable should have black. The other thing, just keep in mind about alternator turn-on speed is all alternators have a charge curve. One is, since they are a one-wire alternator, they rely on residual magnetism to turn on, so they have to be spinning fast enough to turn on. The other thing, too, is when the testers ask you to rev the engine up, or if you're using another piece of equipment, you have to make sure you spin that engine high enough RPM to make sure the alternator is spinning high enough to get full output out to do a fair test. Take a look at all the mounting torque on these things. You're getting ready to connect a tester to it. Is all the hardware good? Who cares if the alternator tests good if it's about to fall off the engine? Belt drive. Some of you have been around for a long time. Remember all the headaches of the Series 60 and all the belt problems they had. That was really a push to go to serpentine system, and what a godsend. It's done wonders for the industry. Are they perfect? No. You have to be careful. Is the tensioner still good? And when I'm getting ready to do an alternator test, I still always reach in there, grab hold of that belt, pull on it. I've found trucks before where had gone down at road service. They didn't have the right belt for it. They put one on that was 2 inches too short. That thing was so tight, it was like a banjo string, and obviously is going to fail soon. Not only that, it could possibly take your tensioner out, could ruin the alternator. That over tension is a very bad thing where it causes radial side load that's going to damage bearings and all those components. When they came out with serpentines and automatic tensioners, they gave us a gauge on them. This one actually shows marks on them. There's another brand that only has positive stops. But again, by reaching in there, pull on the belt, make sure the tensioner moves properly, make sure it seems to be smooth. If you do have the marks on it, take a look at it. There's a minimum and maximum length for that belt. Make sure it's in the sweet spot there where it's going to give the proper tension to it. I don't know if anyone's ever seen these before. These were an inexpensive gauge that was released to be able to check tension on these. Hardly anyone ever uses them now, and again, the automatic tensioners have done wonders for the industry, but there is tools out there that allows you to check the tension on those. Simply re-gauge on them. Why is it important? Again, said before, is radial side load is very rough on the bearings of those. Under tightening, you can have belt slippage, and one thing too with serpentines, you hardly ever will hear the belt squeal that we used to have with V-belts, but it is still slipping. It is going to generate a lot of heat that's going to take out bearings in those units. So, the question a lot of times people give is, how much horsepower does it take to drive this? Well, this is why that belt is so important. That even a 100 amp alternator, it can pull almost 4 horsepower to properly drive it. So, the higher the amperage load, and most trucks now you're seeing up to 280 amp alternator, some over that. So the load on that belt is obviously proportionate to the horsepower to drive that alternator. We did all of our checks, and again, Jimmy covered this in the last episode, but you have to make sure you load test those cables. You can, again, have the best batteries in the world, the best alternator in the world. If you don't have good cabling, connect them, it's not going to work right. I'm going to go back to that previous slide just to cover a couple points, but whenever we do a voltage drop check, the whole idea is we're going to use our tester to simulate our load so that we are doing with a fixed load amount on it, but you're going to put the red on the output terminal, black on either the ground post, or make sure you got a good clean ear to bolt it to, and your external leads you're going to put back directly on the batteries. Tester is going to put a load on that circuit, and while it's under that load, it's going to take a snapshot, look at the voltage at the alternator, and look at the voltage at the battery. TMC RP129 spec is you're allowed half a volt at rated output of the alternator. If you're doing the cranking circuit, you're allowed half a volt at 500 amps. That's the standard test with charging. It's whatever the alternator is rated at, because that's what those cables would have to handle. Also important, if you upgrade your alternator, you spec it with a, say, 150 amp alternator, you're going to replace it with a 200. The only way you're going to get the full advantage of that higher output alternator is you have to replace those cables to make sure they match that higher output rating. Just like we talked about before, if it doesn't meet spec, it's got to be repaired. And that's very important, again, when we go to the actual alternator test, that defective cables can very easily give a lot of the electronic testers high ripple patterns or high ripple voltage that could easily condemn it when it's actually a cable problem. So want to make sure we repair it. Sometimes that can be simply a clean retighten and retest it. Someone worked on this truck before many a times. You look at the starter, someone replaced a starter and left a ground cable off. Well, that ground was very important for the charge circuit. So make sure all the cables are back on it. Make sure you get the stack up right. That again, there may be 10 different cables on there or different wires on that starter because everybody uses a junction point. If you don't get the right stack up, you can wind up with gaps between them because they don't nest right and get a lot of surface area. Make sure they're clean. One OEM uses a compound almost like tar that if you don't get it all cleaned off there, it is a very serious insulator and is going to cause you problems. So make sure it's clean and tight and right stack up. Retest it. So a lot of talking, but I think it's very important we did cover all these things again to make sure that, hey, this is really the 1, 2, 3 is number one is batteries have to be tested. They have to be good. They have to be 100% state of charge or at least above that 12.4 that we talked about before to make sure there's enough energy for the whole system to work properly. You got to look at the belts. You got to look at tension. You got to look at mounting. Do the voltage drop check. Make sure that everything is right in order for that alternator to perform properly. If not, you might as well get some dice and write good and bad on them and roll them and let that determine if the alternator is good or bad. So regardless of what piece of equipment you use, one of the first things you have to do is hop up in the cab, make sure all the loads are off. That it's going to, the tester itself is going to apply that load for you. It has to know what it's doing to get a fair test. And if you've already got headlights on and say air conditioning on, it's going to throw that test off and not give you a fair test. So again, make sure all loads are off. Excuse me. First, we're going to show you a BVA type tester. where it's a much bigger, bench type model. And there's several different ones. There's BVA 36, there's BVA 2000, BVA 2100, the Purkeys labeled products. So they're all still in the same family, but so we call it BVA, for that. But with this piece of equipment, we're going to put our large leads on the battery. We're going to put our inductive clamp on the output of the alternator because it has to read and see exactly what the alternator is putting out while it looks at the voltage at the battery. Once we've made that connection, we want to make sure we have the amp probe pulled, zeroed out properly. So take it off the cable if it's already installed. If not, before you put it on, because we have to make sure it is zeroed. That some of the newer equipment has a zero button on the front of the tester. Other ones, you still have to use the old thumb wheel on the amp probe itself, but we want to make sure we zero out that unit. If you put it on the cable and it already says, positive 25, obviously it's going to throw the tester off and throw all your readings off, and you can easily have a misdiagnosis on that because of being on the wrong one. With the BCT or the handheld unit, with this one's going to work a little bit different as far as connections. We're going to actually hook those leads up to the output terminal and to the ground of the alternator. It does not use an amp probe, so they will just go there. It's going to apply the load there and look at a ripple when it tests the alternator. Now, one other thing I didn't show you here, because again, there's a lot of different examples of software. On any of the electronic testers, they may give you some different questions they're going to ask. One of which is, does the alternator have remote sense? The reason they're asking you that is it may have you connect the remote sense or the external leads to that remote sense post on the alternator. The reason for that, they're going to give you a check that says, hey, whenever I hook that small set of leads to the remote sense, I should see voltage. If it doesn't, it's going to alert you and stop you on the test right there. It says, hey, there's something wrong with that remote sense post, and we need to either repair it or go back and select non-remote sense post if it actually doesn't have it. So make sure you do follow that prompt. Another prompt too is it'll ask, is the vehicle equipped with J1708? Obviously, most of today's trucks do have J1708 or J1939, the data link. There is an option for the electronic equipment where it can give you a cable to connect from the tester and plug into that data link. That allows you to capture the VIN. It can capture engine RPM and a few other pieces of information that will store on the tester. If you don't have that cable or don't want to capture that information, just say no on the 1939. It doesn't impact the rest of the testing at all. So once we have the unit connected, the first prompt's going to come up, and again, doesn't matter if it's the handheld or the benchtop. It's going to tell you to start the engine. Run it at about 1,000 RPM. The reason it's doing this is first is wants to make sure you spun the alternator fast enough to turn on so we can test it. The other thing is it's looking for a change in voltage with that engine RPM. If you have a defective voltage regulator, the faster you spin that alternator, the higher that voltage is going to go. So it's very important we take it to that 1,000 RPM first. Once it does that, and when the voltage is stabilized from, again, if you've done all this in the right order, you've done battery tests, you've done voltage drop checks, you just crank the engine, you've taken some energy out, so we want to make sure we've recovered from all that before we go into the alternator test. Comes up and says allow voltage to stabilize. You should be, right around 14 volts, but again, the biggest and most important thing is that it's stable. It's not, keeping climbing. So once it has, you're going to hit Y to continue. And it'll say rev engine to govern speed. For the output or the amperage section of the test, and at this point we don't care about voltage. We've already done that as the first step, is now we're looking for current. So it's wanting us to take the engine up to govern speed for 10 seconds. The tester, if you do have the ability to run it up to a true govern speed, will notice this and start the test automatically. If you are limited because of the ECU programming on the engine, say it may only let you take it to 1300 RPM, it may not see enough change in that frequency to automatically move to the next section. So if that's the case, you have to hit Y to continue. But it'll stay at this for 10 seconds while it does the test. Again, at this point, we really don't care about voltage. We're looking for current, and we're looking for ripple pattern to see how that alternator is performing. That if an alternator is starting to fail, that you have a diode starting to go bad, you have a stator starting to fail. If any of those things start to fail, your AC ripple will start, increasing and get way above the norm, and that's what this tester is looking for. At the end of that 10 seconds, it should come back and tell you basically the overall health of that unit. It says, hey, good regulation. We were there at 13.98. We saw no high AC ripple. We know the diodes are good, output's good, everything is good. The exception is if you are using the benchtop with the clip-on amp meter, that is going to actually give you a number result. And says, hey, you put in that it was a 200 amp alternator, it checked it, put out 190, 210, whatever. Basically, rule of thumb is within 10% of rated output, because as alternators especially get hot, they do lose some performance, so the general rule of thumb is within 10% of rated output. But the end of it here tells you, hey, there is nothing wrong with this alternator. Now, again, going back to our comment before about cables, though, if you did have defective cables, they can generate that at high ripple, and it could tell you you had a defective alternator because those cables were way out of spec. So again, make sure you do all these things and fix them in the right order to do a proper test on the system. So with this, you should be done. If you happen to have a test where the alternator didn't even kick on, ran the test and the voltage never climbed at all, it's definitely never got anywhere near voltage or the regulation voltage, you may have an alternator that has lost its residual magnetism. Before you condemn that alternator, we have what's called flashing the R terminal. This could be a brand new alternator that's been on the shelf. If you drop an alternator just right or handled it, it can cause it to lose that residual magnetism. Another thing I've seen is when someone's doing an in-frame or doing a lot of work, they took that alternator off and it's been on a big steel table in the shop, it can cause those things. So before you condemn that alternator, you can very easily just take a jumper wire, go from the output terminal to either the I or the R, and you'll see a little flash, and suddenly this alternator works again. That's generally when the alternator OEMs will get trouble not found type units. And when we talk about alternators, it's either the alternator lost its residual magnetism, or again, people didn't do it in the right order and misdiagnosed an alternator for one of those two reasons. And do we have any questions? I say it looks like a fairly slow day for questions. Looks like crickets today. Oops, I had one come up. We had one question. What is a remote sense letter on terminal for alternator? Most alternators will just have an R or RS. Some will say it as remote. But generally, it is somewhat clearly marked for remote sense on that. Another question was, can I test an alternator only using a voltmeter? Technically you can, but it's not a very accurate test by any means. That yes, if you put a voltmeter across the battery and say it was 12.5 and you started it and the voltage climbed up, is it working? Yes. Is it working right? No way I can answer that. Because again, you could have a defective alternator that, yeah, it's putting out some, but maybe not anywhere near what it's rated at.